There is an object in the universe so extreme that it breaks our understanding of physics. A point where gravity becomes so intense that not even light can escape, where space and time themselves are crushed into a singularity. We call it a black hole. And today we are going to talk about what would happen if one came for us. A stellar black hole forms when a massive star exhausts its nuclear fuel and collapses under its own gravity. For millions of years, the outward pressure of nuclear fusion balanced gravity perfectly. The moment fusion stops, that balance breaks. The core collapses in less than a second. What remains is the entire mass of a stellar core compressed into a point of infinite density, a place where our equations of physics produce infinities, where mathematics breaks down completely. Around that point is the event horizon, an invisible boundary defined not by any physical surface, but by the curvature of space-time itself. Cross it, and you cannot return. Not because something stops you, but because every path forward in space-time leads inward. There is no direction called away. What if one was heading toward Earth? You would never see it coming. Black holes emit nothing, reflect nothing. A stellar black hole hurtling through interstellar space would be essentially invisible. The only warning would come from its gravity. The first effects would be subtle, slight perturbations in the orbits of the outermost planets, Neptune drifting slightly, Uranus tilting. Decades or centuries before arrival, astronomers with precise enough instruments might notice, if they were looking in the right place. Most likely, no one would notice until it was far too late. As it drew closer, the effects would escalate rapidly. Jupiter's orbit shifting, Saturn's rings distorting, Mars wobbling, and the tides on Earth beginning to intensify in ways that would baffle scientists before they understood what was approaching. At roughly the distance of the moon, things would become catastrophic. The ocean would surge toward the black hole, creating a permanent tidal bulge thousands of kilometers high. The crust would crack along every fault line simultaneously, volcanoes erupting globally, earthquakes of magnitudes we don't even have instruments to measure, shaking the planet without stopping. The atmosphere would begin stripping away in sheets of superheated gas. And then, long before the black hole actually reached Earth, Earth itself would begin to stretch. Physicists call this spaghettification, the gravitational pull on the side of Earth closest to the black hole dramatically stronger than on the far side. That difference pulling the planet apart along its axis. First like a football, then like a thread. The atoms of what was once a planet stretched into a thin stream of superheated plasma spiraling into the black hole. Earth would cease to exist as a structure, in minutes, and the black hole itself would not even notice. A stellar black hole has a mass 10 to 50 times greater than our sun. Earth is a crumb. The entire mass of our planet, swallowed, would barely register. The black hole would continue its journey through the galaxy, completely unchanged. We would be gone, and the universe would continue as if we had never existed. But here is something almost comforting. Black holes are not cosmic vacuum cleaners. They do not pull in everything around them. If our sun were replaced by a black hole of identical mass, Earth would continue orbiting exactly as it does now. Nothing would change except the light. They are dangerous only when you get close enough for the tidal gradient to become catastrophic. And the nearest known black hole is 1,500 light-years away. The probability of one on a collision course with our solar system is extraordinarily small. We are safe in our small, warm corner of the Milky Way, orbiting a gentle, middle-aged star. But the universe contains things so extreme, so utterly alien to everything our senses evolved to perceive, that even describing them requires language borrowed from science fiction. Singularities where physics breaks, horizons you can cross but never return from, forces that unmake planets like wet paper, and they are not fiction. They exist, right now, hundreds of millions of them, scattered across every galaxy in the observable universe, silent, dark, out there in the void.